give you an acronym that you can easily use to remember this, and that is oil rig. Oil rig. So what does oil rig stand for? Oil rig, O means oxidation is loss. Oxidation is loss of electron. Can you see our oxidation? Good afternoon today. Now some of you requested that we take the topic redox reaction. So today we'll be looking at redox reaction. Now redox is a combination of two words, reduction and oxidation. So you can simply define redox reaction as a reaction in which reduction and oxidation are occurring simultaneously. I'm going to use 6 different parameters to define redox reaction very quickly, and I want you to pay attention. But before we proceed, please do well to hit the subscribe button if you have not done that, and then turn up the notification bell so that anytime we post a new topic, you can always get a notification. Thank you very much. Now let's talk about redox reaction. So redox, like I said, is gotten from two words that are combined, reduction and oxidation, and that gives you redox, okay? So you can simply define redox reaction as a reaction in which reduction and oxidation occur simultaneously. Simultaneously means as reduction is occurring, oxidation is occurring. But let's try to break down what oxidation and reduction is before we begin to look at a reaction where both are occurring simultaneously. So the first parameter I will be using is oxygen. So in terms of oxygen, but before I proceed, you see it's important to know that oxidation, redox goes beyond oxidation or goes beyond oxygen. I know a lot of you already understand that oxidation is addition of oxygen, removal of oxygen is reduction. And some of you also know about hydrogen, but today we'll be learning some more deeper things about redox reaction. So in terms of oxygen, oxidation is addition of oxygen. So this is copper and oxygen reacting together to give you copper 2 oxide. So if you look at this reaction, on the reactant side, copper is only standing alone. But by the time it got to the product side, you have copper 2 oxide. So copper has been oxidized to give copper 2 oxide. And that is what oxidation is, while reduction is the removal of oxygen. E.g., this is copper 2 oxide on the reactant side. By the time it gets to the product side, it becomes copper and oxygen. So copper is standing alone. So that means oxygen has been removed from copper 2 oxide, and this is reduction taking place. The next is in terms of hydrogen. In terms of hydrogen, addition is simply in terms of hydrogen, addition is, okay, so what applies to hydrogen is the reverse of what applies to oxygen. You know, for oxygen, we said addition of oxygen is oxidation, but for hydrogen, addition of hydrogen is reduction. So reduction is the addition of hydrogen, e.g., this is ethane C2H4. If you react hydrogen gas with it, it's going to give you ethane. So this is reduction. So you can say ethane can be reduced, or it can go through reduction to give ethane. While oxidation is the removal of hydrogen. For example, if you see ethane C2H6, if you remove hydrogen from it, so minus H2, it's going to give you ethane. So this is ethane, and hydrogen gas is removed. So this is what you call oxidation. So now let's look at the next parameter. So the next parameter we talk about is in terms of electron transfer. That's number 3. In terms of electron transfer. So let's try to define. So in terms of electron transfer, oxidation is simply the loss of electron, while reduction is gaining of electron. So let me give you an example. If you look at sodium, At the elemental stage, at the neutral stage, the oxidation number of sodium is oxygen is 0. Sorry. So when you get to this point, you have Na plus electron. So at this point, sodium was a metal, all right, standing alone, elemental state. But by the time it gets here, it has given out electron, and therefore the oxidation number of sodium has increased from 0 to +1. So that loss of electron is what you call oxidation. So this is oxidation. Then if I have chlorine, right, chlorine, by the time it gains electron, it becomes Cl minus. This is reduction. Reduction is gaining of electron. So at this point, the atomic number of chlorine is 17. So the electronic configuration will be 287. But by the time it gets here, because an extra electron has come in there, it becomes 288. Alright? So because it's gained an electron, the electronic configuration has electron number has increased by 1. For sodium, here it's 281, that's 11, but here it's 280. Why? Because one electron has been lost, given us. So that loss of electron is called oxidation, while the gaining of electron here is called reduction. Action here is the loss of electron. Why Rig means reduction is gaining. I believe that's very simple. So reduction is the gaining of electrons, so you can easily use oil rig to remember this parameter. The next one, which is the fourth one, is in terms of oxidation number. So in terms of oxidation number, let us try to define redox. So oxidation simply means increase in oxidation number, while reduction means decrease in oxidation number. So for example, let's see this sodium plus chlorine to give sodium chloride. The oxidation number of sodium here is 0, because anytime an element is standing at the elemental stage, okay, as a neutral element, the oxidation number is 0. The oxidation number of chlorine here is also 0. But at this point, the oxidation number of sodium is no longer 0. If you ionize sodium chloride, you are going to have Na plus Cl minus. That means the oxidation number of sodium has increased from 0 to +1 in this reaction, and this is what you call oxidation, right? While the oxidation number of chlorine from 0 to -1, is that an increase or a decrease? That's a decrease. That is what you call reduction. So this increase is what you call oxidation, that is increase in oxidation number. Alright? So sodium has gone through oxidation from 0 oxidation number to +1 oxidation number. So that is increase in oxidation number. Number 5. Let's talk in terms of electronegative elements. So what are electronegative elements? Electronegative elements are simply elements that have high electronegativity. They are the non-metals, elements in group 6, group 7, alright? They have high tendency to become negatively charged by accepting electrons, by gaining electrons. So anytime you add that kind of element to another element, alright? So something happens to that element. So let's see what happens in terms of electronegativity. So oxidation can simply be defined as is the addition of electronegative elements. So for example, sodium plus chlorine. Oxidation of sodium here is 0, chlorine is 0. Chlorine is an oxidizing agent, or it's an electronegative element. So by the time you have sodium chloride, can you see oxidation of sodium increase from 0 to +1? You remember here with the Na plus minus. So that increase in oxidation number is as a result of addition of an electronegative chlorine. So anytime you add an electronegative element to another element, then oxidation occurs. Alright, so this is oxidation. Well, this is reduction. So we are going to see from the other part. Oxidation is the addition. So let's pick it just one after the other. Therefore, reduction is the removal of electronegative elements. So let's say sodium chloride to give you Na plus Cl. 0, 0. If you ionize it, it's still +1, -1. So by the time we, on this reactant side, chlorine and sodium were together, sodium chloride, so sodium had an electronegative element to it. But by the time sodium gets here, it's now standing alone. We had removed the electronegative chlorine from it. So the oxidation number of sodium here is +1 and here is 0. That is a decrease. So what do you call decrease in oxidation number? It's called reduction. So let me repeat, addition of electronegative elements, alright, is called oxidation, while the removal of electronegative chlorine from this compound is called reduction. Alright? Then the last, which is the sixth parameter we'll be using, is in terms of electropositive elements. Number 6, in terms of electropositive elements. So what are electropositive elements? They are simply elements that are highly electropositive. That is, they have the tendency to become positively charged by giving out or by losing electrons. And these are usually the metals. They are in group 1, 2, and group 3, right? Like sodium is in group 1, potassium is in group 1, calcium is in group 2. These are highly electropositive elements. So if you have, so let's see what happens. Oxidation. So whatever happens to electronegativity or in terms of electronegativity, the reverse occurs in terms of electropositive elements. Okay? You remember we said in terms of electronegative elements, we said addition of electronegative element is oxidation. So this time around, oxidation will be removal of electropositive elements. Removal of electropositive element. So for example, if I have sodium chloride and then I have sodium plus chlorine, 0, 0, here +1, -1. Now at this point, chlorine had an electropositive element here, alright? And the oxidation number of chlorine here was -1. But by the time it got here, the oxidation number of chlorine becomes 0. From -1 to 0, is that an increase or a decrease? Yes, you are right. That is an increase. So the oxidation number of chlorine increases from -1 to 0. That is increase in oxidation number, and that is oxidation. Why? Because we had removed an electropositive sodium from it. It's now standing alone here. Alright? While reduction is the what? Opposite, which is addition of electropositive element. For example, if you have Na plus Cl to give NaCl, 0, 0, +1 if you ionize, -1. So here, chlorine had oxidation number of 0. But by the time it gets here, it becomes -1. That is reduction, that's decrease in oxidation number. Why? Because an electropositive sodium element has been added to it. So bringing about reduction. So reduction is addition of electropositive element. I believe that is clear. Okay, talk about reducing agent, oxidizing agent. Alright? Reducing agent, oxidizing agents. Now there are certain things you need to know. Number one, anytime they ask you for reducing agents or oxidizing agents, the agents will always be on the reactant side. Oxidizing agent will always be at the reactant side. Reducing agents will always be at the reactant side. None of it will be at the product side. Are you with me? Then they can ask you which species or which element has been oxidized or reduced. The answer is also going to be at the reactant side, not at the product side, because it is the oxidizing agent that will be reduced. So we are going to talk about that. So number one thing to note is that the oxidizing agent and reducing agent are always on the reactant side. Number two, the oxidizing agent cannot be oxidized. Rather, it oxidizes other elements. Itself is reduced. So, oxidizing agents cannot be oxidized, rather it will be reduced. So, because it is an oxidizing agent, it oxidizes another person. So, let me give you an illustration. You know, when somebody comes and says, I am a change agent, it comes and it changes things, okay? And by the time he changes everything, he himself does not change, even though he changed everything. Alright? So a change agent changes things, but himself is not changed. The same thing applies here. Oxidizing agent oxidizes things, but itself is not oxidized. Rather, itself is reduced. While a reducing agent reduces others, but itself is oxidized. Is that okay? So the oxidizing agent will define them. The reducing agent cannot be reduced. It is oxidized. But it reduces other species or other elements. It reduces other elements. Remember, I told you that oxidizing agents and reducing agents cannot be at the product side. So if they tell you which of these following has been oxidized, has been reduced, the answer will be at the reactant side. So the oxidizing agent will be the one that has been reduced, while the reducing agent will be the one that has been oxidized. Another thing you should know, you never find oxidizing agents in an oxidation chain. But in reduction chain and vice versa. So that means if you draw an oxidation chain, so look at this example. This is an oxidation chain. So if they ask you which of these two are the oxidizing agent, I cannot call this the oxidizing agent because this is an oxidation chain. So what I will find here is the reducing agent in an oxidation chain. Are you with me? Then in this, in this oxidation chain, I find the reduction or reducing agent. And in this reduction chain, I find that oxidizing agent. So this guy is the oxidizing agent, this guy is the reducing agent. So let me break that down in a clearer term for you. So if I have sodium plus chlorine have sodium chloride. And they ask you, who is the oxidizing agent, who is the reducing agent? Oxidation power of sodium here was 0, becomes +1 here, that's increase. So this oxidation. Chlorine was -1, becomes 0 here, that is from 0 to -1, that is reduction. Okay, decrease in oxidation. So in this oxidation chain, I cannot find an oxidizing agent. So this is going to be my reducing agent, and this is going to be my oxidizing agent. So if they ask you who is the oxidizing agent, it's chlorine. Who has been oxidized? This oxidizing agent cannot be oxidized. So it is sodium that has been oxidized here to sodium chloride. While this reducing agent has been oxidized, this oxidizing agent has been reduced. Is that okay?